Okay. First thing I want to do before we talk about today's lesson is review yesterday. All right. Yesterday, we said that if you had a function in this form, that you could use the information that was inside of the equation for the graph. Well, and then I told you yesterday that you didn't need to do a table of values. Some of you, all you did was table of values and you didn't graph anything. And some of you, all of your graphs were the same. So as I was looking through your papers, I'm like, some people miss the boat or just blatantly don't listen at all. Because the only way the graphs would all be the same is if every equation in the assignment yesterday was exactly the same. And they weren't. Okay? So we said yesterday that if you have an equation in this form, now this f of x could also just be a y. That the sign right here, okay, positive, if this a is positive, the graph goes up. And if this a is negative, then the graph goes down. Okay? Remember that? And then we said that this value of a right here, that if this was less than 1, all right, anybody remember? Yeah, 1 was regular, less than 1 makes it wider, right? That was called compression. Like a wide graph. If that value was greater than 1, all right, that was called stretch, which makes taller, skinnier graphs. Okay? Some of you wrote compression for every graph. Well, this a value wasn't the same in every graph, right? It was different. Every graph should have looked different yesterday. Then the vertex of this whole thing, or let's see, this value in here, this moved the vertex Anybody remember what that did to the vertex? In here. Didn't it move it left or right? And how? Move the vertex left or right. The same as the number or the opposite? The opposite of the number. Move the vertex left or right, opposite. And then this right here, this value, what was to the right of the parentheses, what'd that do? One more, last thing. That moved the vertex. Where did that move the vertex? Up or down? Exact. Meaning if this was a positive 1, it moved the vertex up 1 from 0, 0. If this was a negative 2, it moved the graph down 2. Okay? So all of that information is contained in each of the equations that you had yesterday. And all of your graphs should have been different. Because today you're going to be doing the same thing, except the equation is going to be in a different form. All right? This form right here yesterday was called, I'm pretty sure it's called vertex form. Yeah, vertex form. This was vertex form. All right, I just felt like I needed to cover that. I make sure that you understand that those graphs from yesterday, they shouldn't have all looked the same. So we'll move on to today's lesson, which is going to be standard form. Of a quadratic equation. All right, standard form of a quadratic equation. Right here, function of x is equal to ax squared plus bx plus c. All right, so when an equation is in this form, it could be f of x equals, or it could be y equals, either one. Again, the value in front of the x squared, this a, the positive or negative of this determines the up or downness of the graph, okay? So just like yesterday, if a is positive, this graph is going up. If a is negative, this graph is going down. We're going to say if a is greater than 0, all right, graph opens up. And if a is less than 0, which would be a negative, the graph opens down. All right, opens up would look like this. Opens down would look like that. Axis of symmetry, a little more complicated today. The axis of symmetry is located at the opposite of b over 2a. All right, the opposite of b over 2a. Y at the vertex is found by substituting x, substituting, boy, it looks like a lot of t's, by substituting x back into the equation. The y-intercept of the graph is at 0 and c. The value of c out here. And what else? Graph it. Vertex form. Okay, so first part of your assignment today. You're going to be asked to identify the vertex. Axis of symmetry. Min or max value. And the range. Vertex, axis of symmetry, minimum or maximum value, and the range of each parabola. And we're going to do that right now for y equals x squared plus 2x plus 3. Okay, so the first thing we got to find is the vertex. And even before we do that, let's identify the A, the B, and the C. The A value right here is equal to 1. Your A is, when it's in this form, it's whatever's between the equal sign and the x squared. Your B value of this equation is the 2. And your C value of this equation is the 3. So we need the vertex. First thing we need is x at the vertex. All right? X at the vertex is equal to the opposite of B divided by 2A. So in this case, we're going to have the opposite of B, which is 2, divided by 2 times 1. So this is the opposite of 2 divided by 2, which is negative 1. So vertex, our x value at the vertex is negative 1. To find the y value at the vertex, we need to take this negative 1 and we need to substitute it into the equation. So we're still working on this vertex. We're going to say that y is equal to negative 1 squared plus 2 times negative 1 plus 3. So our y at the vertex, negative 1 squared is 1. This goes plus 2 times negative 1. So it's going to be plus negative 2, or it's going to be minus 2 plus 3. And 1 minus 2 is negative 1. Negative 1 plus 3 is positive 2. So your y at the vertex is equal to 2. There's your vertex, negative 1, 2. The second question was the axis of symmetry. Well, just like yesterday, your axis of symmetry is your x value at the vertex. So the axis of symmetry is x equals negative 1. You need to find the minimum or the maximum. Since A is positive, this graph is going to be opening up. So does it have a minimum or maximum value? If it goes like this, it's got a minimum value. And its minimum value is going to be y at the vertex. All right, so its minimum value is 2. And then range, your range. Your range of values. When you're talking about the range of values, domain range, you're talking about the y values. Since this graph goes up and it has a minimum value of 2, then the range of values for this graph are going to be y is greater than or equal to 2. All of the y values in this graph, if you were to plot it on the coordinate plane, all of the y values would be greater than or equal to positive 2. Because the minimum value of this graph, the lowest point of this graph, is right here at y equals 2. And that came from y at the vertex. Yes, no, maybe? What will happen as you start working through the practice is this will get faster and faster and faster and faster, because you won't have to look back up at your notes to find x at the vertex. All right. And as soon as you see the vertex and the value of a, you'll know if you're dealing with a minimum or maximum value. All right. So let's try one more of these. We're going to do the same thing this time for y equals negative 2x squared plus 2x minus 5. So our a is negative 2, our b is positive 2, and our c is equal to negative 5. Is this thing going to go up or down? It's going down. Good. It's going to look something along these lines. It's going to go down, all right, because a is negative. So we need the vertex. We need x at the vertex. All right, so our vertex, our x at the vertex is equal to the opposite of b. So our b over 2 times our a, right here, which is a negative. This is, in the numerator, you got a 2. In the denominator, you got 2 times negative 2, which is negative 2. I'm sorry, negative 4. The opposite of 2 over negative 4 is going to be 1/2. Everybody understand that? Negative of a negative, right? It's positive. So your vertex is going to be at 1/2, comma. You got to figure out what y is at the vertex. So our y at the vertex is equal to negative 2 times 1/2 squared plus 2 times 1/2 minus 5. Be a good time to start using your calculators, because you can do 2 times 1/2 squared let's see, that's 1/2 times 1/2 is 1/4 times 2. Go plus 2 times 1/2. Yeah, I'm not going to do that. So we got -2 times 1/2 squared. That's 0.25. Plus 2 times 1/2. That equals 1 minus 5. So -2 times 0.25. That's -0.5 plus 1 minus 5. So we got 0.5 negative plus 1 minus 5, negative 4.5. So right here, our y value at the vertex is negative 4.5. Axis of symmetry. I'm going to go over here. Our axis of symmetry is going to be at x equals 1/2. Since the graph goes down, it's got a maximum value. Our maximum value is negative 4.5. Our range. Look at the range now. Since this graph is going down, all of our y values are going to be less than or equal to negative 4.5. So there's all the data you need about those graphs. Vertex, x and y at the vertex. Axis of symmetry, min or max value, and the range of the vertex. I want to show you, if you were given this equation, and you have to identify your A, your B, and your C. All right, in this form, your A is what's between the equal sign and the x squared. So that's a -1 in this case. Your B is what's in front of the x. In this case, this is a -1 as well. And your C value right here, when there's nothing out there to the right, when there's just not a regular old number sitting out there, then your C value is 0. For an equation like y equals 2x squared plus 5, what's your A value here? Now, do you see how there's nothing in the middle there in front of the x? There's not a number in this equation in front of the x, so that makes your B 0. And your C value now, that's this positive 5. Got it? Now, the problems that I'm going to give you today, your practice for today is going to be page 206. Eight through 25. What I want you to do, I need you to listen now. 8 through 16, you're doing what we just did. You're finding the you're finding the vertex axis of symmetry, minimum or maximum in the range. You're doing those 4 things. Okay? For 17 through 25, it says to graph the function. For problems 17 through 25, for 17 through 25, find vertex, axis of symmetry, min or max, and the range. But your graph doesn't have to be a technical graph, okay? But what your graph does have to be is it's got to be different. It's got to look different for each problem, okay? You need to show me that your graph, when you're graphing 17 through 25, I'm going to say and graph. You need to show me whether it's going to go up or down. All right? And whether it's going to go up or down, and whether it's going to be fatter or skinnier than the standard graph. Okay? So you're still finding the same information for 17 through 25, but you got to sketch a graph. You don't have to do a table of values to sketch your graph. All you have to do is what I did up here. All right? You just got to show me that this thing's going down. And in this case, it probably would have been better to show me that, all right, this thing's going down, right? And is it going to be thinner or wider? It's going to be stretched, right? So look, it's going to look more like this. That's all you need to show me on the graphs. That it's going down, it's going to be thin. And you've listed all this other information. When you have to graph something like this, okay, this y equals x squared plus 2x plus 3. Show me that it's going up, all right? And show me that it's shaped like the parent function. It's just a normal shaped graph because your a was 1. If your a becomes greater than 1, show me that it's getting skinnier. If your a is between 0 and 1, show me that it's getting wider, all right, that it's compressed. That's your assignment for today for these problems. All right, so if you're in class, it's time to get to work. If you're an e-learner, you're excused from the Zoom meeting to go work on your assignment and get it sent in. So this is going in the basket, or you're emailing a picture at the end of the period